Okay, section 5 is going to be on properties of logarithms. There are actually about 5 or 6 properties that we'll look at in this. Your book only highlights 3 of them. So I'll tell you the 3 that the book highlights, and then I've added an additional 3 that I think will be kind of useful as we move forward. So before we actually start doing some problems with these properties, we're going to prove them first. I know how much you guys love proofs, but I think that it would be in our best interest if we prove them first before we just start using them. So the first one that we're going to look at is this one. Log base x of a times b equals log base x of a plus log base x of b. As we go through these, I would at least write down what the properties are. That way you have them with you down in your notes at the same time. So looking at this one initially, it looks like a single log with a base and multiplication on the inside is going to turn into 2 logs with the same base separated by addition. So let's go ahead and let's dive into this one. In order to get started, we're going to have to define some of our variables. So the first thing that we're going to say is let's let x to the y power equal some value. We're going to call it a, and we're going to say let's let the same base x to some power z equal b. We can define them that way. I know that looks like a lot of variables in there, but notice on each one we have the same base x raised to a different power, which then means that we should get a different value out of it. We've done that several times. And now what we're going to do is we're going to convert these. We've converted them quite a bit. So let's convert x to the y equaling a from exponential to logarithm. So we're going to have now log base x of a equal y. And over here then we should have log base x of b equal to z. Perfect. Those green ones are going to come back into play later on. Now let's actually take our 2 scenarios. I know it looks kind of crazy right now, but let's take x to the y times x to the z. And if we do that, x to the y we said was the same thing as a, and x to the z we said is the same thing as b. That goes back up to the purple ones. Okay, keep moving. With same bases, we add exponents. So we should be able to go x to the y plus z now equaling a times b. And from there, to solve for an exponent, remember, logarithm means what is the exponent. This may seem kind of weird, but we're going to take a log on both sides with a specific base, call it x. So log base x of x to the y plus z equals log base x of ab. Okay, and essentially what that allows us to do, this will be a property that I'll show you later on too, but essentially on the left side, everything just kind of cancels. This log base x, grab a different color, let's maybe use yellow. This log base x of x really just goes away, and it's going to give us then y plus z equaling log base x of a times b. And then we have one last step. Remember I said that the green up there at the top was going to come back into play. That's actually your last step. So when I look at it, y plus z, y we said is the same thing as log base x of a, so I can substitute that in. log base x of a plus z we said was the same thing as log base x of b, and substitute that in, equals log base x of a times b. And you can see just how that works out to play, that when I have multiplication, it can be separated into addition. That is your property. Also what we had at the very top. Okay, so that's property number one. Property number two is almost identical, but instead of using multiplication, it's now division. So I think I'm going to skip over this one because they act in the exact same way. But instead of multiplication, now you just have division. So I would take a sec to write that down, and then we'll go on to property number three. In property number three, we're going to use quite a bit. And it looks like this. Log base x of a to the n equals n log base x of a. So essentially that exponent is allowed to move to the front of a logarithm. If I get rid of that 3, this exponent right here can move all the way in front, right there. Okay, so let's actually prove that one. So in order to prove this, we're going to start with the left, and we're going to try and manipulate it so it becomes the right. So we're going to say log base x of a to the n is going to equal some value, call it y. From here, we're going to pull out our favorite scenario where instead of dealing with logs, we're actually going to deal with exponential. So we're going to convert this thing to exponential form. My base is x, my exponent is y, and that should equal a to the n. Now I actually want to get a by itself. Just some manipulation. You could get x by itself if you wanted, but we're going to say let's get a by itself. And in order to get a by itself, if I want to get rid of something to the nth power, I need to take it to the nth root. Or, instead of using nth roots, let's say we take it to 1 over n, which means the exact same thing. So when I do that, then I'm going to get x to the y over n equals just a, or a to the first. N times 1 over n is 1, just like 2 times a half is 1. Means the same thing. And now we're going to convert it back into logarithms. If I convert it back into a logarithm, we're going to have log base x of a equals y to the n. And then one last step, let's get y by itself. If I get y by itself, that means I need to multiply both sides by n, leaving me with n log base x of a equal to y. And look at that. From my beginning, I started with the left, and that was equal to y. And now I got the right side from up above, that n log base x of a, that was the right side, is also equal to y. Which means then that I have log base, your property, log base x of a to the n equals n log base x of a. And that's your property. Okay, those first 3 properties, those are the ones that are in the book. The other 3 aren't near as long to prove, but are going to be quite handy. This one's pretty trivial, and it comes out really, really quick. If you convert this to exponential, you're going to get the same thing on each side. So if I convert it, we're going to say our base is x to our exponent, a, equals x to the a. That is a true statement always. So if you ever get this scenario where I have the same base as this location right in here, you know it's equal to just the exponent. Very quick property. Another quick property is this one. Log base x of 1 equals 0. Again, convert it to exponential and it makes perfect sense. Your base is x Your exponent is 0 equals 1. One of your properties of exponents is whatever some base to the 0 power equals 1. That's always true. You can test anything. 2 to the 0 equals 1. Property. And I think that might be the last one. Yep, it is. So those are all your properties that you're going to use in section 5.